Hi, this video is on fuel cells, what they are and how they work. As you can see from the picture here, this car would have an electric motor in the front instead of a combustion engine, and instead of petrol or diesel being filled in there, he's actually filling in the tank with hydrogen. Okay, so this is a hydrogen fuel cell, and hydrogen is the fuel, and the oxidant is oxygen from the air, and the waste product is going to be water instead of carbon dioxide and particulates and other nasty stuff. Okay, so that's an example of a fuel cell. There are other examples of fuel cells like methanol fuel cells, for example, but in this video we're just going to have a look at the reactions that go on in a hydrogen fuel cell. So what we're going to do now is look at a schematic of a hydrogen fuel cell to see what reactions go on at the electrodes and therefore how the electrical energy is produced. So this little rectangle is going to represent the casing around the cell, and then of course we need an electrode, so this is going to be an anode. Let's just label those while we're at it. So this is casing, metal casing. This is our anode. In between the anode and the cathode we need a membrane. I'll explain why in a minute. And then of course we need a cathode for another half reaction to happen. And then because this is a cross section we need some more casing here. Okay, so that's our cross section, and the reason it's set out like that is because this can represent where our hydrogen fuel is coming in, and this can represent where our oxidant is coming in. And when the hydrogen comes in here at the top, it's going to react on the catalytic surface of the anode, and the reaction is going to be our hydrogen is going to split up into two hydrogen ions, and it's going to release two electrons, like so. Now the thing is that this membrane, which is made of a polymer, I'll just put that in brackets, it's a selective membrane that only lets the hydrogen ions through. Okay, so these hydrogen ions can go through and they can get to the cathode to take part in another reaction. However, the electrons have to go into the casing, right, and they're going to go off in this direction, and we'll complete that in a minute. Let's come back to the hydrogen ions. The hydrogen ions have got all the way to the cathode now, and the oxygen has come in this other inlet valve, and so the reaction that's going to go on here is some oxygen gas is going to react with our hydrogen ions and some electrons, and it's going to make some water. Yeah, and so these electrons have come along here. They've gone through a motor, come back in through this casing, and found their way over here to take part in the other half reaction. That should have been water, of course. And so now what we can see is that we've got two half reactions, and together they're going to make this reaction. So we've got some hydrogen gas, we've got some oxygen gas, and we're making a water molecule. And in the process, that enthalpy change has been converted into electricity and has run a motor, for example, in a hydrogen car or bus. So they are the reactions that happen at the electrodes of a fuel cell. And the important part is that instead of creating heat in an exothermic reaction, we've created electricity by using this membrane to selectively allow hydrogen ions through, but not the electrons. And so the electrons have to go around a circuit and in the process do some work in an electrical motor. Okay, so that is an acidic hydrogen fuel cell. An acidic hydrogen fuel cell. And you can also get an alkaline fuel cell. So let's use the same arrangement of our casings and our electrodes. All right, so this is still going to be our anode. This is still going to be our cathode. Our oxygen is still going to come in here, and our hydrogen is still going to come in here. But in this case, our membrane, instead of being a polymer, is potassium hydroxide in a paste, right? And instead of just letting hydrogen ions through, it lets hydroxide ions through in this direction. So the hydroxide ions come through the membrane. We'll see how they're created in a minute, but they're replaced rather. But they've come from the potassium hydroxide membrane, and they're going to react with our hydrogen. So the hydrogens come in, and it reacts with some hydroxide ions, and it's going to make some water. And in the process, we're going to get a couple of electrons. Right, the electrons can't get through this membrane, right? So they have to go through the casing again, and like before, they go through a motor, come back through the casing, and end up at the cathode. Okay, so at the cathode, the reaction that happens here in an alkaline fuel cell like this is that our oxygen, and just balance it while we're at it, our oxygen reacts with some of the water that has been made in the anode reaction, and it gets together with these electrons that have come around the circuit and makes some hydroxide ions. And these are our hydroxide ions that end up replacing the hydroxide ions that were from potassium hydroxide in the membrane. Okay, so we've got slightly different half reactions, but the overall reaction is the same. If you add the two half reactions together, we've still got half O2 and some hydrogen making some water, like so, and the energy that's, that reaction creates, that difference in enthalpy between the product and the reactants, instead of making heat, is in this case it's making electrical energy, because we stop the electrons and we force them to go around an electrical circuit through a motor and do some work that way. All right, so here's the thing, is that when we do that, when we make the energy electrical energy instead of heat energy, that is quite efficient, and so we get most of the energy, a high proportion of the energy that's available is created into electrical energy, and so that's one of the advantages of a hydrogen fuel cell. So lastly, let's have a look at the pros and cons of hydrogen fuel cells, and let's do a couple of pros and a couple of cons, writing them out here. So as far as the pros are concerned, you might have heard me say that they are efficient. So the efficiency is obviously a pro. So the amount of the energy of the reaction that you make into electricity is quite a high percentage compared to if you were, say, to burn the hydrogen and use the heat produced to drive pistons in a combustion engine, for example. So the efficiency is high. Also less waste, The only waste product is water, and we're not getting any carbon dioxide or particulates coming off, so that's good. On the con side, of course, we have that there's no infrastructure. There's no infrastructure. There's very few service stations where you can fill up with hydrogen, and it's expensive to refit your car. So if you wanted to switch your combustion engine into a hydrogen fuel cell, then that would be expensive. All right, and also it would require specialist mechanics, of which there are not many. So there's a couple of pros and a couple of cons, and that's it for hydrogen fuel cells.